Olá, esta é a série áudio sobre IP e workflow no rádio, da trilha 7 Rádio do 7 Experience Academy. Neste módulo, vamos discutir mais alternativas para transportar o sinal composto através de redes IP e estabelecer links estúdio-transmissor. O nosso convidado para discutir soluções e algumas dessas tecnologias é o Kirk Harnack, Senior System Consultant da Telos Alliance. Bem-vindo, Kirk.
Hello, I'm Kirk Harnack. I'm the Senior Solutions Consultant at the Telos Alliance. I also am part owner of some radio stations, and I get to do some consulting here and there around the world from time to time for radio stations. So I'm extra pleased to bring you this presentation about a technology called Micro-MPX. It's brought to you in the Omnia MPX Node. The MPX Node is a purpose-built broadcast appliance for delivering FM composite signals over high-speed and mid-speed IP networks. By transporting an FM composite signal rather than left and right audio, broadcasters can keep their on-air processing and RDS encoding at the studio, and then deliver a transmission-ready, peak-controlled FM signal directly to the FM transmitter without the need for transmitter-end peak limiting or stereo generation. Each MPX node can be set to either encode or decode, and a pair of them creates an end-to-end system. Let's take a quick review of the FM composite signal so we're all on the same page. Remember, the FM composite signal, that's what comes out of a stereo generator, consists of a mono audio left plus right signal, plus the stereo pilot, plus that dual sideband suppressed carrier left minus right stereo audio signal. It's often called the stereo subchannel. And then you may have the FM RDS signal at 57 kilohertz. Well, many FM radio stations, both in the USA and around the world, use composite or multiplex radio links. In the US, these are typically in the 950 megahertz RF band as point-to-point links. In this scenario, an FM station's audio processor and stereo encoder are at the studio. The composite or MPX link carries this wideband MPX signal to the transmitter site, where it can go directly to the station's FM exciter and transmitter. Now, the downsides of this kind of link are, they're a little bit expensive with outdoor antennas and good quality coax, plus the radios themselves. There is often RF congestion, especially in big cities. Sometimes you get atmospheric fading if you have a long path. There is added noise. There's added distortion and overshoots, and any of these audio impairments that occur in the STL link will be transmitted by your FM transmitter. So if there's some noise, some distortion, some fading, some less than perfect signal, well, that gets transmitted by your FM transmitter to all of your listeners. Well, it's possible to sample and digitize the MPX output of an FM audio processor and stereo generator. However, the data rate or the bandwidth that's required to accurately carry this MPX signal is pretty large, several megabits per second. Well, Micro-MPX is a mathematical data reduction algorithm that's designed specifically for the unique FM composite signal. A pair of Omnia MPX nodes can encode and decode the MPX signal faithfully while transporting it over IP links. It could even be over the public internet. The bandwidth required is about 400 kilobits per second. You don't need an FCC license for this kind of STL or whatever your governing authority is. It can be used as a main or maybe as a backup. Honestly, it's cleaner than an analog STL system. Plus, it transports the RDS data, and there's no overshoots at all, and there's no psychoacoustic encoding artifacts. Here are the specifications for the Omnia MPX node. I won't go over all of them. I won't read all of them to you, but there's an encoder and a decoder. That's just set by a dip switch. It's the same hardware. And on the back, let's take a look at the back side. There's the composite connector, and that's the traditional BNC connector. It can be either an input or it can be an output, depending on the setting of the dip switches inside. It has a configurable GPIO for local monitoring and control. It has two Ethernet connections and a 12-volt input power supply. It's on a captive connector, so it won't fall out. The Omnia MPX node works with any FM processor. It does not have to be an Omnia processor. Any processor that puts out analog MPX can go into the Omnia MPX node. The Micro-MPX data signal is carried over the public internet or a private IP link to the transmitter site, where the decoder node decodes it and takes it to the transmitter. Now, some Omnia processors can be purchased with the Micro-MPX encoder option in it, or you can turn it on with a license purchase. So you might want to check into that possibility. Then you don't need the hardware Omnia MPX node at the studio, just at the transmitter site. What can you do? Well, besides sending from one to one, that is one studio to one transmitter, you can do multiple unicast and send the same signal to, in this example, 2 different transmitter sites. Or you can buy an extra license and send to 4 or 8 or I think even 12 transmitter sites if you want to. That does take a lot of bandwidth, though, at the studio, because these are each an individual signal. There's another method of sending signal, and that's with multicast IP distribution. Now, this doesn't work over the public internet, but if you have a wide area network or other network that does handle multicast, then you can send one signal to the multicast network and pick it up at many different sites. You can use a wired internet or wide area network to carry this data. Again, it's only about 400 kilobits per second. Or you can send this data over, for example, an IP radio link. You could also send this data by satellite if you want to. And it does offer dual path IP. So you can send over 2 different WAN or internet links, or even an IP radio link and a internet link. Whatever combination you want to. It will handle the packets and splice the packets if there are any missing from the other link. You can use MPX nodes as a backup or as a main STL. Now, let's hear from a gentleman who has actually used the Micro-MPX technology and the MPX nodes in Sweden. It's Niklas Stromberg.
Hi, my name is Niklas Stromberg and I run the company NSP here in Sweden. I've been in the radio business since about 1983. Since I sold my first Telos product in 2016, my work has become so much easier. In addition, customers have become so much happier, and here, MPX node is a part of this.
First example. Here is their transmitter network before I was involved. As STL, they had a quite noisy RF link feeding their main transmitter. The network has also 3 translators which listen to the main transmitter. On a Friday afternoon, their STL simply signed off. 2 days of dead air until the new box arrived. After this, they called me. I did build their studio 3 years earlier, but since I installed Axia, I didn't need to visit them so often anymore. As a start, I installed an Axia MPX node on their main site. They were so happy with that, I got an order for another site. Site number 4. Now I'm waiting for their next investment. Shortly, there will be MPX nodes on all their sites. And the best of all, the RF noise and rebroadcast defects are gone. On the site, it looks like this. The network service provider leaves a point-to-point fiber connection that is used by the MPX node and the UPS. As a bonus, the site can now be monitored. The next example is from a customer which have their studios in Sweden and one of their transmitters in Denmark. They used regular IP codecs, which works fine for a few years, but suddenly the communication was lost. The codecs has been hijacked. I got a call and quickly I went to the customer with 2 of my SIP ones. The issue was solved and the customer was happy, but this was only a temporary solution. I got an order for an MPX node which was installed immediately, and now they have a secure audio connection. And their network bandwidth consumptions is much less than before. Thanks to the MPX node, the customer did not need all the equipment they had on their site. Equipment that could be used for other purposes. Maybe as a stair step.
Earlier, I said that Micro-MPX was a cleaner way to send audio, multiplex audio, than a traditional analog STL. And here's proof. These are 2 different spectrographs from a radio station in Canada. The left-hand one is over their traditional analog MPX STL. Now, they do have good signal on their STL, but the technology of analog wideband RF transmission only allows for a certain signal-to-noise ratio. In this case, the noise, as you can see, is about 65 or 70 dB down. Whereas on the right-hand side, This is the output of an Omnia MPX node. You can see the noise is 95 to 100 dB down. And so you're not transmitting noise. With an analog MPX STL, your FM transmitter will transmit all of that noise. But with the Omnia MPX node, you get a very noise-free signal and only get the signal that you want to actually transmit. Here's an example of what the dashboard page on the MPX node looks like. And of course, you do use a browser to go into it, to check it, and to configure it. By the way, the interface is optimized also for use with a mobile device. So it's really easy to check on your station with a browser in your phone. So the Omnia MPX node can be a really good value to broadcasters. As a main STL, a backup STL, it's a simple no-frills solution, it's easy to set up, and it gives you high-quality MPX transport at a reasonable bandwidth. I'm Kirk Harnack. Thank you for your attention. It's great to talk to you, and I'm really excited to share this technology about micro-MPX with you.
Obrigado, Kirk, pela apresentação e pela sua participação na trilha 7 rádios do 7 Experience Academy.